Hello all, this is our review sheet for our Unit 10 exam on acids, bases, and salts. So a substance is classified as an electrolyte if it can conduct an electric current. That is a definition. A student tested a 0.1 molar aqueous solution and made the following observations. It conducted electricity, so that means it could be an acid, base, or salt. It turns blue litmus red. This probably means it's an acid. And it reacts with zinc to form gas bubbles. So this definitely means it's an acid. Therefore, the best answer choice is HBr, or hydrobromic acid. Which of the following aqueous solutions is the best conductor of electricity? Well, acids, bases, and salts are conductors of electricity. That does knock out a couple of answer choices, like these two alcohols. But the two sodium hydroxides are both bases, and the one that's the best answer is going to be the one with the stronger concentration. So choice 4. Now we have the compound sodium hydroxide. It dissolves in water, and what does it yield? So it dissociates in the water, and it produces aqueous sodium ions and aqueous hydroxide ions. Of course, the only negative ions present in this solution are hydroxide, so the best answer is 1. Which substance is an Arrhenius base? Just check table L before you make any decisions like this. And table L tells us right away that KOH is a base, so there's my answer. How are HNO3 and CH3COOH similar? Let's check table K. So one of the things I can discover about HNO3 and CH3COOH are that they are both acids on table K. So they are Arrhenius acids, and they would turn blue litmus red. Just for interest here, there's a similar answer below that says red litmus blue. Actually, only bases can turn red litmus blue. That's why I chose 1. Number 7. When an Arrhenius acid dissolves in water, the only positive ion in the solution. So here's hydrochloric acid, which is an Arrhenius acid, and we're going to dissolve that in liquid water, of course. And it will dissociate, and it's going to produce aqueous hydrogen ions, but it'll also produce aqueous chloride ions. So I think the best answer here is going to be 1. Number 8, the only positive ion found in an aqueous solution of sulfuric acid is I'm looking through the answer choices because this is similar to the last one. And I can cross out some things like hydroxide, no, that's base. Sulfite, no, that's base. Sulfate, no, that's base. So it must be hydronium, but why? Because I had said hydrogen earlier. Well, if you take a look at this equation, you can just put a hydrogen ion in the presence of a molecule of water. And this is going to go through an equilibrium reaction, by the way, but they can bond together to make H3O, and the plus will come with the H, that extra H as well, so H3O plus. And right here on the right, we've got hydronium, and on the left, we've got hydrogen. So basically, anytime you have hydrogen, you also have hydronium. So the best answer, of course, is the hydronium ion. Number 9, which compound is an Arrhenius base? We could check table L if you're not sure. So while I don't see an exact match on table L, what I do see is like a suggestion for a match. So NaOH is an example of a binary sort of base where you have just one element from group 1 and then a hydroxide. So that's really similar to number 3, which is lithium hydroxide, but so similar to sodium hydroxide. Okay, number 10, we have a solution whose pH is 3 and another solution who is Z and has a pH of 6. How many times greater is the hydronium ion concentration in solution A than the hydronium ion concentration in solution Z? So basically, in solution A at pH 3, you are fairly acidic. Solution Z, whose pH is 6, is definitely less acidic. And I'm making that judgment because the higher you go on the pH scale, the more base you are, the more alkaline you are. Furthermore, every pH unit you move on the pH scale is actually worth a change in concentration of times 10. So if you move 3 units on the pH scale the way we have here, as we went from 3 to 6 or 6 to 3, you're actually doing times 10 times 10 times 10, or 1,000. All right, so that basically narrows the answers right down. So the answer is going to be 1,000. In solution, let's see, Z, you have a pH of 6, so that's 1,000 times less acidic, or in solution A, it's 1,000 times more acidic. Moving forward, we want to know a hydrogen ion H plus could also be written as, well, that one's easy. We just talked about this one, but it's H3O plus. Number 12, which statement correctly describes a solution whose pH is 9? Well, if your pH is 9, that does mean you're a base, which also means that your concentration of hydroxide is more than your concentration of hydronium or hydrogen. So let's see if I can narrow anything down. So it's not number 1, which is indicating that it's acidic. And it's not number 3, which also indicates that it's acidic. So all I was looking at were concentrations there. But it also, in number 2, it refers to causing litmus to turn blue. So bases do that. So let's see if that, let's leave 2 in the running. And then in number 4, it says that it would cause methyl orange to turn red. Let's check table M. So as you can see, methyl orange doesn't turn red until it gets below the 3.1 endpoint, so only from 0 to 3.1, which is far, far below 9. So it's not going to be 4. And that does also tell us that the answer must be 2. So the last 2 on this page, which pH change represents a 100-fold increase in the concentration of H3O+. So firstly, increasing the concentration of hydronium is more acid or lower pH value. And secondly, doing it by 100-fold is to change by 2 pH units, and that is to decrease by 2 pH units. So that should narrow the choices right down. We need to fall 2 pH units. It looks like from 3 to 1 is our best answer. And number 14, which indicator is yellow in a solution with a pH of 9.8? Let's check table M. So the solutions that turn to yellow on their upper endpoint would be maybe methyl orange. It's really my only option that turns yellow on the upper endpoint, where 9.8 would be. But methyl orange 9.8, yeah, it's going to be methyl orange. Basically, it turns yellow at 4.4, so 9.8 is above that. So methyl orange works. So guys, for this question where it says, in which solution will thymol-blue indicator appear blue, we do know that we need to choose a base, and we will also need to use table M to see what the pH range changes are. So let me pull up, in addition to table M, table L, so that I can see where are my bases. I can see right here KOH is definitely a base, and there it is listed as well. KOH, potassium hydroxide, is a base. I will highlight that. And also, this is for thymol blue, so we know that its pH is going to change to blue after pH 9.6. So all the signs are telling me to choose choice 2. KOH is a base. After 9.6, which is the base range, we should get blue, so I think 15 is choice 2. Now for number 16, they just want to know which equation represents a neutralization reaction. A neutralization reaction is one between an acid and a base that produces water and a salt. And the answer choice just jumps right out at you. It's choice 3. It says you have an acid, HNO3, in this case this is nitric acid, reacting with potassium hydroxide base to make this potassium nitrate salt and water. So moving on from that question, let's do number 17. Which reactants form the salt calcium sulfate in a neutralization reaction? So as the question suggests, I'm sort of working backwards on this one. I know that water and the salt, calcium sulfate, will be products of this reaction. And I know that I will have an acid in some form, so it'll have some number of H's. And I know that I'll have a base in some form, that'll have some number of OH's, because those guys are going to be making the water on the right-hand side. But what I haven't talked about so far is the calciums and the sulfates. So the calciums are probably going to go with the hydroxide, because this is positive and these are negative. And the sulfates are probably going to go with the hydrogen because hydrogens are positive and sulfates are negative. But in terms of equalizing charges, I do have to point out that sulfate has a -2 charge, so we are definitely going to need 2 hydrogens to balance that. And additionally, the hydroxide has a -1 charge. So the calcium being +2, I'm going to need 2 hydroxides to balance that 1 calcium. So parentheses and a subscript. And that is the reaction. So my choice is definitely 3, sulfuric acid and calcium hydroxide. In number 18, we're going to be asked to do the exact same strategy, but this time we're going to be moving forward. So in this case, we have sulfuric acid reacting with barium hydroxide. So we all know that it's going to produce water as one of the products, which is going to take care of the OHs from the barium hydroxide and the H's from the sulfuric acid. What this is not taking care of so far is the sulfates and the bariums, and that is what is going to make my salt. So this is going to be a barium sulfate compound. Barium does have a +2 charge, and sulfate has a -2 charge. So this is going to be aqueous, but otherwise 1-to-1 ratio. So the best answer choice for question number 18 is number 4, barium sulfate. Number 19, what volume of 0.5 molar nitric acid must completely react to neutralize 100 milliliters of 0.1 molar potassium hydroxide? This is a titration equation. So HNO3 is my acid, and they want to know what volume I am going to have of it. So I am looking for VA. I'll isolate now, divide with MA on both sides, and you'll get a revised equation of MV/VB over MA. I'm going to plug in variables that I know. So I plugged in the variables that I knew, and I was able to find an answer of 20 milliliters, or choice 2. Same idea for number 20. How many milliliters of 0.1 molar sodium hydroxide would be needed to completely neutralize 50 milliliters of 0.3 molar HCl? In the question, they're asking me for the number of milliliters of sodium hydroxide, so I am looking for VB. Let's isolate now. Divide by MB on both sides, and you will find that VB is actually equal to MAVA over MB. Let's plug in variables that we know. So I just did all that sort of plugging and chugging, and I got 150 milliliters as my answer, which would lead me to choose choice 3. 21, which process uses a volume of solution of known concentration to determine the concentration of another solution? Well, this process that they're discussing is the math that I was just doing. This is called, of course, titration. Number 22. A student neutralized 16.4 milliliters of HCl by adding 12.7 milliliters of 0.620 molar KOH. What was the molarity of the HCl? So I was able to determine from the question when they asked what's the molarity of the HCl that they're looking for MA. So I'll start isolating that now. Apparently MA is going to be equal to MBVB over VA. So I just ran those numbers, and I got the answer 0.480 molar. So, of course, the best answer choice is choice 2. Let's do another one. When 50 milliliters of an HNO3 solution is exactly neutralized by 150 milliliters of a 0.5 molar solution of KOH, what's the concentration of HNO3? So we are being asked for the molarity of nitric acid. So as I isolate for MA, I'll divide by VA on both sides. And MA will come out to be MBVB over VA. And I'll plug in variables that I know. So I did just plug in those numbers, and I was able to get 1.5 molar as my answer, which would mean that my answer choice is choice 2. Okay, let's do one more titration equation. If 5 milliliters of a 0.2 molar HCl solution is required to neutralize 10 milliliters of NaOH, what is the concentration of the base? So I'll need to show my equation. I'm looking for the molarity of the base, so let me divide by the volume of the base on both sides. The molarity of the base is going to be MAVA over VB. So I was able to find that the answer to this is going to be 0.1 molar. So of course the best answer is number 1, 0.1 molar. And last up is one of the easiest ones, thank gosh. What is an electrolyte? Electrolytes are substances that can conduct electricity in solution. And great electrolytes are either acids, bases, or salts. And of the answer choices that I can see right here, the only one that meets any of those requirements is CH3COOH. You can even see it here on table K. It's called ethanoic acid or acetic acid, and it is an acid and an electrolyte. So I hope you feel like that covers everything from Unit 10, acids, bases, and salts, and I wish you all the best as you study for your exam. Thanks for watching.